Okay, so let's get started. We're going to be taking a look in this training module at how to set up a flex fuel based tune using our traditional fuel equation mode. Now, the last tutorial we talked about how to set up a flex fuel based tune using the modeled mode. That's easier to integrate for our flex fuel tuning feature. Link makes that possible through some of the multi-blend fuel blending options we have in the software that's specific to the model mode. Now, when we get into traditional, we're going to find that has that math modeling in the background to account for the ethanol concentration. So we have to get creative of how we can implement some custom strategies within the software so that in traditional mode, we can do a flex-based tune and still have the same results if we were calibrating and tuning in the model mode. Let me go through how to set some things up here. We're going to go through first, making sure that the ethanol content sensor is registering and reading correctly. And then we're going to go through how to set up the tune using some compensation tables to account for the ethanol content so that we can get our fuel sorted out first. Then we'll talk about how we can deal with spark timing and some of our cranking fuel. Those are specific for working in ethanol-based fuels. And then we'll also talk about if you're turbocharged and you're doing closed loop boost control, how you can integrate working in that closed loop control to vary the target based on ethanol content. So we have some of the programming capabilities as we would with the model mode, but some things are stripped away. And again, it forces us to get a little bit creative here in the software. Okay, so let's go here from our basics page, and we're going to move across here first into our digital input page. The digital input is where we're going to set up our ethanol content sensors. We need to make sure that this is configured correctly before we do any calibrating and tuning. So looking here under our source, we're going to go from none, and we're going to choose the digital input we've assigned for that flex fuel reading. I have it set here for digital 2 as my source coming into the link box here. So we're going to go ahead and click OK, and that's going to be where the signal is broadcasted. Now we have to go in and turn some things on and configure some things. The pull-up resistor typically is going to be left on, and that's going to be allowing that circuit to actually complete and to work. And we can see the status if the sensor is reading and working. As soon as we turn that pull-up resistor on and assign the input for the link, we can take a look here under our DI2. We see that it's active. And then here we see that our ethanol content is showing 10%. Now this is correct for my fuel that's in my fuel system. I have petrol fuel from the gas pump in the United States. We have 10% ethanol blended with our fuel in most locations. So this is about what you'd expect to see. Now, if you're on ethanol-free gas, this should read approximately 0. That way you know that your ethanol content sensor is actually calibrated and reading correctly. So you just want to take a look at what that's showing. Now, taking a look here, we're going to find we have our active edge. This is important when we're talking about working in the model mode. Specifically, the active edge here will either be rising or falling. We typically choose rising as the correct option. When we choose the incorrect option, so if we choose falling for our sensor, what that does is skew the fuel temperature reading coming out of your ethanol content sensor. So not only does it broadcast a 50 to 150 hertz signal proportional to the ethanol content in a linear scale, it also outputs a fuel temperature reading in a duty cycle format for the link to interpret as well. So it's kind of unique and interesting that signal broadcasts both a duty cycle and a frequency, and that's how it knows fuel temperature and ethanol content. So if we select the incorrect option here, if we jump into our fuel, and then if we jump here, we can actually see we're logging right now. We can take a look here. The fuel temperature reading will be incorrect. We're going to see this is extremely high at 200 degrees Celsius. It should match approximately to what your ambient temperature is reading. If it's a cold fuel system, a cold engine, you should see that your air temp and your fuel temperature are pretty close to each other. So in this case, if you jump back in here real quick, go to digital input. I have it set to rising, which is the option that you want to select. If you have it set to falling, that does give you the incorrect fuel temperature reading. Now, it's not that important when we're talking about working in our traditional mode because we're not accounting for the fuel density when we're talking about traditional calculations. We know how this works. It's super easy how we have everything configured here. We have our master value for fuel. So we see our master fuel value here. That's going to be the overall scalar injector pulse width. And then we have our table, which is going to be a percentage of that master fuel. And then it also takes into account our map pressure. And then it gives us a base pulse width. We add the latency dead time to that. We add the short pulse width to that. We get a final correct injector pulse width. So super easy how all this works. So if we take a step back here to digital, if we have the incorrect active edge selected. So we're rising versus falling, or falling versus rising in this case. It gives the incorrect edge. It doesn't really affect anything. Everything is still going to work in terms of how we're implementing this for the traditional mode. But technically speaking, if we have the correct sensor installed and we have the correct active edge here installed, that'll give you the proper field temperature reading. Now my sensor, I purposely have this sensor. It's a knockoff GM Continental sensor that I got for a couple bucks, 20, 30 bucks online. I purposely chose this sensor to show you, even though the edge is selected correctly here and the ethanol content reading is correct, I am still getting an incorrect field temperature reading. That's usually one way we can determine real quickly if the sensor is going to work with the link or not. Now again, traditional mode, there's no real downside to having one of these knockoff sensors, other than they might be cheap quality and may not work long-term compared to a GM Continental, but the field temperature here isn't going to be doing anything. So we can just see it's going to read whatever it's going to read. In this case, it's reading incorrect, but it's not going to affect us. The fuel density calculation isn't a part of the traditional fuel equation mode. All right, so looking here, let's jump into our digital input. Now we do have a couple additional things to talk about. There is a frequency filter. This is going to be used to filter your ethanol content reading. I have almost never had to use this filter. Out of the box, the Continental sensors are pretty robust and they're pretty stable in the reading. So very, very rarely do I even have to use any of the filter options here. I would start with it set to none and then just monitor what your ethanol is reading. If you're noticing it's kind of glitchy and bouncing all over the place, I would first honestly check your ground source for your ethanol sensor. They should be grounded to a sensor ground, although sometimes I do have to ground them to chassis ground. Sometimes it stabilizes the reading. So keep an open mind with that in terms of that ground for the ethanol sensor, but the frequency can be used to smooth out your ethanol content reading. Now the next thing is going to be your ethanol sensor fault value. If the ethanol...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.